Okay, here's another example, and what we're going to do here is use that alternative convention for summing the voltages. All right, so I've labeled my I1 in this direction, I2 in this direction, I3. So the consistency factor is to label the voltages. So if the current's going this way, that's plus minus. Current going this way, that is a plus minus. Current going this way, that is a plus minus. All right, we've got a node sitting over here. Okay, so what we're going to do then is we're going to take a loop here. So let's call that loop number 1. And we're going to sum the voltages around that loop. And let's say in this case, we're going to go clockwise. Didn't matter which way. So let's label this loop number 1. And we're going to sum the voltages with this alternate approach. All right, so as we go around the loop, the first terminal we come to is the negative terminal of that source. So since it's the negative sitting here, we're going to call that a minus 20. Coming on round, we hit the positive. So we're going to call that a plus I1 times 1K. Coming on around, we hit the positive over here first. So we're going to call that a plus I3 times 3K. Back to the beginning, all of that is equal to 0. All right, so that's our first loop equation. All right, what could we do here? Well, look, we could take the 20 to the other side if we wanted to. And we could say we've got I1 times 1K, and then we've got a plus I3 times 3K, and all of that is equal to 20. All right, so there's our first loop equation. All right, second loop over here. So let's call this loop number 2. All right, so loop 2. In the case of loop 2, let's just go the other way. Doesn't matter again. So starting, let's say here, we're coming around. What do we hit first? We hit the plus sign first, so we're going to call that a plus 10. Okay, coming on round, we hit the plus sign first. We're going to call that a plus I2 times 2K. All right, coming on round, we hit the plus sign again first. So we're going to call that a plus I3 times 3K. And we're back to the beginning, and all of that really is equal to 0. All right, so if we wanted to rearrange this, we could say, what could we say here? We could say that, look, we've got to take the 10 to the other side, perhaps. We could say we've got an I2 times 2K plus an I3 times 3K, and all of that is equal to 8 minus 10. And we could say, there we go, we've got our second loop equation. Once again, as we've said in the past, you know, we've got how many unknowns? We've got 3 unknowns, the 3 currents here, so we need one more equation, and the other equation that we're going to get is really a summation of currents at that particular node. And we're going to still use the same convention. If the current's going in, we're going to call it positive. If it's going out, we're going to call it negative. So we've got what? I1's coming in, I2 is coming in, and I3 is coming out, so we'll call that a minus I3, and all of that is equal to 0. So now all we really have to do is really take these 3 equations and really solve then for the I1, I2, and I3. All right, solving this then, these are the equations that we had derived on the previous page. Let's see if we can solve. So we're going to take the I3 to the other side, so we're going to say that I1 plus I2 is equal to I3. And then let's substitute this I3 into here, and we're going to substitute it into here. All right, so we'll have 2 equations basically with 2 unknowns. So let's take the first one here. So what have we got? We've got a 20 is equal to I1 times 1K plus, open up a bracket, what's I3? I3 is I1 plus I2, close the bracket, that's times 3K. Let's expand this out, and if we do that, what do we get? We get 20 is equal to I1 times 1K, and then we've got a plus, let's have a look, we've got I1 times 3K, and we've got a plus I2 times 3K. Collecting our terms together, we've got 20 is equal to I1. How many I1s do we have? We've got a 1K here and a 3K over here, have we not? So that's a 4K. And then how many I2s? Well, we've just got a plus 3K times I2, or I2 3K. All right, what's next? let's operate on the next equation over here. So we've got a minus 10 is equal to I2 times 2k. We're substituting for what? I3 over here. So let's put that in. Open a bracket up. That's I1 plus I2, and that is times 3k. All right, we're going to simply expand this out. So we've got a minus 10 is equal to I2 times 2k, and then we've got a plus I1 times what? 3k, and we've got a plus I2 times 3k. We're going to collect all our terms together now. Okay, so we've got a minus 10 is equal to, how many I1s? We've got I1 times 3k, and what else have we got? We've got, how many I2s? I've got 2k here, and I've got 3k over here, so that's really a plus I2 times 5k. All right, so we've got now this equation in terms of what I1 and I2, and we've got the other equation sitting up here really in terms of I1 and I2. And so we simply now need to solve those two simultaneous equations. So here are those two equations. Now I'm going to solve. So let's see, maybe I'm going to take this one as we've done before. I'm going to take this one over here. I'm going to multiply this guy by 3, and I'm going to multiply this guy by 4. Okay, so if I do that, what do I get? Well, 3 times 20 is equal to what? That's a 60. It's equal to, I'm multiplying this by 3, so that's an I1, that's 12k, isn't it? Plus I2, that's a 9k, isn't it? Yep. Okay, I'm going to take this guy and we're going to multiply it by 4. So I've got what? A minus 40 then, sitting here, is equal to I1 times what? 12k. Then I've got a plus I2, 4 5s are 20k sitting over here. All right, so what am I going to do here? Well, I think what I'll do is I'll take this equation and subtract this one from it. Okay, so that's a 60 minus a minus 40, which gives me 100. That is equal to, well, I've got 12k I1s, 12k I1s, so I'm subtracting that from that, so I don't have any I1s. I'm left with what? I2, I've got a 9k I2s, and I'm subtracting a 20k from it, so what does that leave me? Yeah, well, that's going to leave me with a minus 11k, does it not? Times basically that I2. So therefore, I could say that I2 then is simply equal to what? It's equal to a minus 100, and that's divided by 11k. And so I've solved really for I2. So what we can now do is what? Go back into any one of these equations, here or here, and we can substitute that value for I2 in there, and we could determine I1. And then once we know I1 and I2, we can get I3, and then we can solve for any of the voltages associated with that particular circuit. All right, you might want to compare this to this same problem that was actually done a little while ago, and see that the results are exactly the same. Okay, I'll see you next time.